Hello everyone, in this video we are going to see about the bus arbitration algorithms which are dynamic in nature. The last video we have seen about the static algorithms. Now we will see the dynamic algorithms. As the name implies, the static algorithms has the fixed priority that helps to arbitrate the signals among the processors or the resources or the devices. Okay. Now the dynamic algorithm has some technique by which the access to the bus is given in a random manner. Let us see first of all what is bus arbitration. The bus arbitration is a procedure by which the active bus master accesses the bus, relinquishes the control of it and then transfer it to the different bus seeking processor unit. As we know that it comes under the multiple processor technique. So each processor has its own purpose to solve, and they have the common shared buses, and they also need different resources. So now the bus always helps to transfer the data between different devices, memory and the CPU. So in order to transfer those control those data, we need the buses. So the bus has to be arbitered, that means changed among the processes. So in order to do this, we are using the system is using the bus arbitration method. So what does it do? It gives the active bus master accesses to the bus, and after the bus helps to transfer data, it relinquishes the control of it and then it transfers the control to some other devices which is requesting the bus. So that is the bus arbitration technique. And let us see that by coordinating the actions of all the devices seeking memory transfers, the bus arbitration method is used to resolve these disputes. So in the case of dynamic algorithm or any algorithms, it has to coordinate the actions of all the devices, because one device may seek a memory read, another device may seek for a memory write, and some device may transfer for IO. So many devices ask the control of the bus for different scenarios. So accordingly, the bus control or the bus master has to coordinate all the actions to decide which processor or which device has to be given the bus control. So that is the resolving the disputes by the bus arbitration method. Now let us see the mechanism. What is the inter-processor mechanism? The inter-processor arbitration is a mechanism that used to handle the multiple requests from the bus. As we have just seen here, there are many resources, many requests for the bus occurs when the bus is needed for different scenarios. A bus master has to decide which device will get the control of the bus. So the arbitration techniques are of various one, which is the serial and the parallel arbitration techniques. In the case of static arbitration techniques, we have two methods: serial arbitration method and parallel arbitration method. This comes under the static arbitration technique, which we have seen in the previous video. Now let us see about the dynamic algorithms. What is the dynamic algorithm? Is the serial and the parallel bus arbitration are static since the priorities are assigned or fixed. That means there are some procedure or logic to decide which device will get the control of the bus. So that is the static, which is fixed in advance. But in the case of dynamic, that is not the case. Priorities of the system changes when the system is in operation. So while the system is in active mode, it may require some resources that may be urgent in nature, and some devices may request the device which is not urgent. So based upon the situation or the scenarios, the bus arbitration techniques chooses the bus control to different devices. That is called as a dynamic arbitration. There are various algorithms that is used in the dynamic arbitration techniques. One such technique is the time slice. What does the time slice means? It is like a real-time system where it allocates a fixed length time slice of the bus time offered sequentially to each processors in a round-robin fashion. What is round-robin fashion is there will be a time quantum. It is a fixed time slice, maybe 2 seconds, 2 nanoseconds or 3 milliseconds, whatever the devices units may be. Accordingly, for that period, the time for that time slice, the control is given to one particular arbiter or the device. After the time is over, the control given to the next consecutive time slice to the next devices. So the services provided by each system component and the system is independent of this location near the bus. So it is not like the bus static where the signal is given based upon the distance. Now it is only based upon the services which is needed in a time fashion, that is a time slice. So every processor will get a time slot of its own. It will do its process, and when the time slot is over, it has to pass the control to the next device which is in the action. And now next method is the polling. In polling, the controller generates the addresses for the devices. That means the polling technique has some logic which generates the addresses for the devices. And the number of addresses lines needed depends upon the number of connected devices to the system. For example, if there are 2 devices connected, it will be 2 power 2, 4 lines will be there. Address lines will be there. So accordingly, the devices will be chosen for the control. The controller generates a sequence of device addresses in response to the bus request. So when a bus request is received by the arbitration technique arbiter, it will generate a sequence of device addresses, and then when the requesting devices recognizes its addresses, it activates the busy bus line and uses the bus. So for example, if device 1 comes in the calculation or in the request, so if it is happens that device 1 get the control, so automatically 1 will access the bus. Device 1 will access the bus and it uses its control for some for its need, how long it is needed. Here there is no time slice, it is only how long it is needed. So after its purpose is over, it will pass the control to the next other devices. So after several bus cycles, the polling process continues by choosing a different processor. So the polling is a technique that generates the addresses. So limited addresses will be there based upon the devices attached. So randomly the different devices will be addressed. Accordingly, the device will get the control. The polling sequences usually is programmable, and as a result, the selection priority can be altered under the program control. That means the programmer can program it to get the logic of this dynamic arbitration techniques. So as the name implies, it is dynamic in nature. So any device will get the bus control anytime. Next is the least recently used called LRU. This algorithm provides the highest priority for a device, requesting that it has not been used the bus for too long. The priorities are adjusted after several bus cycles according to the LRU algorithm. So here, as the name implies, least recently used. For example, there is a device which has not been used for long time. Okay, then what happened, this that particular device will be given the priority, highest priority. So let it use the bus cycle for some time and relax the control. Okay, so this algorithm provides the highest priority for a device, requesting that it has not been used the bus for long time. So it didn't ask for long time, let us give the priority. It has been waiting for a long time without asking, so why not you give the priority for the particular device. So that way the algorithm chooses the least recently used technique. The next one is the first in first out. Requests are served in the order received in the FIFO scheme. We know that FIFO is the queue scheme, so the request comes in the queue, and the first will enter the queue in the first and the last will enter the queue in the last. So automatically whichever first in the queue will be given the control of the bus, so that it will be serviced. So once for example, there are 5 devices or 5 requests inside the queue, the first request will be granted. After the first request is over and relaxes the control, then it passes the control to the second one. So that is called as an first in first out algorithm. So each processor has to wait for its bus usage time as per first in first out technique. So this is how the dynamic algorithm chooses the priority. Now next is the rotating daisy chain. What does it mean is, it is a dynamic extension of the daisy chain algorithm. We have seen the daisy chain algorithm in the static mechanism, static arbitration techniques. Now here the extension which gives some dynamic sense to the rotate, that is a daisy chain algorithm, which is the rotating daisy chain. There is no control, there is no central bus controller in this scheme. That means there is no common bus controller. The priority line is connected from the priority out of the last device back to the priority in of the first device in a closed loop. We have seen in the static algorithm, the first PO is connected to the next PI. That means the priority out signal of the highest priority arbiter will be passed to the second priority in. Likewise, the second priority out will be passed to the third priority in. Likewise, the chain goes. Now here the extension, the difference that is done is only connecting the priority in. For example, there are 5 devices. The output of the 5th priority device is connected to the first priority input. That means it forms a loop. When it forms a loop, naturally what happens, the daisy chain algorithm rotates again. That means the again whichever processes may not get the priority so long in the static technique, the now this time, since there is a loop is formed by connecting the last priority output to the first priority input, the different devices will get different chances to get the bus control. So that is the technique extension of the daisy chain, which is the static algorithm. Okay. Now each arbiter priority for a given bus cycle is determined by the position along the bus priority line from the arbiter whose processor is currently controlling the bus. So here a bus cycle is granted means for a small duration of time the bus is given the control, that is called as a bus giving a bus cycle. And how to give the bus cycle, that is determined by the position along the bus priority line from the arbiter whose processor is currently controlling the bus. That means now the currently some processor N will be having the bus control. Okay, so now from that the distance, it is determined by the how long the bus cycle. Actually this bus cycle determines the position. Now a new device or new arbiter may ask a bus control. In that time this algorithm will decide the whose processor is currently controlling the bus. So accordingly it will decide which has to be selected the next. So it will break the static concept of daisy chain algorithm. And once an arbiter releases the bus, it has the lowest priority. That means soon after a particular arbiter uses the bus, it has to be given only after some time. That is called as an it will become the lowest priority. That means since you have just uses the bus control for recent time, it has to be given only control for after some time. That means the priority will be set as the lowest priority which just release the bus. So this is how the dynamic algorithm uses these techniques such as the time slice, which is the round robin, and then the polling technique, as well as the first in first out, which is the queuing of the priorities, and also the extension of the rotating daisy chain algorithm. Hope this is easy to follow and understand. When the question is asked for dynamic arbitration algorithms, this part of this answer is enough. In case the question is asked for generally discuss on the bus arbitration algorithms in a multiprocessor architecture. If that is the question, you have to combine the answer from the previous video, which is the static arbitration algorithm, plus this dynamic algorithm, which is a 15-mark question or a higher percentage question. Okay, I hope it is easy to follow, and thanks for watching.